Hi, my name is Charles Woolridge. I'm an applications engineer for GoEngineer. Today's webinar will cover CAMWorks lathe operations, specifically groove and thread operations on the OD and ID. The part that we'll be working with today, you'll notice it does have an internal groove, it has an external groove, it has an internal threaded portion, and then the external threaded portion will be along here. And again, we're looking at a section view, and this is what the part looks like fully. For those of you familiar with the CAMWorks mill workflow, today's webinar will use the same familiar workflow. We define the machine, we set up the coordinate system, stock size, and turn setup. We extract machinable features, and then generate an operation plan. And then we generate and simulate toolpaths. And finally, we post-process and transfer the resulting file to our NC machine. Looking at the part in SOLIDWORKS, let's kind of generate a rough plan on how we want to machine this part. The way I want to machine this part is I want to start machining this side first. So this will be lathe operation 1. I'm going to do a face operation, rough and finish. I'm going to turn the OD a little bit, just here, this little chamfer. I'm going to do a groove operation. That's going to be the rough and finish here. I'm going to do a drill operation. And then I'm going to do a bore to size, rough and finish. And then I'm going to thread this internal ID. And that'll be lathe operation 1. Again, the machine plan for lathe operation 1, which will be running on a Haas ST20, is we're going to do a face operation, rough and finish. We're going to turn the OD. We're going to do a groove, rough and finish. We're expecting a drill operation, a bore operation, rough and finish, and then a thread operation on the ID. Using the SOLIDWORKS CAMWorks workflow, first thing we need to do is define our machine. In SOLIDWORKS, we come to the CAMWorks 2018 tab, and we go to the far left-hand side to the Define Machine icon. When we define the machine, you'll notice that there's a number of tabs, but we'll start from left to right. Machine, we want to change it from a mill machine. We're doing a turn part, so we'll go to Turn Single Turret. We'll select that item. The next tab over is the Tool Crib. We want to select the Tool Crib 1 rear inch empty, and this tool crib will get filled up when we do our generate our operation plan and tool paths. Let's go to the post processor. We said we want to use the Haas ST20, so let's go ahead and select that item. Posting, we want to start with program number 1, and then because we're on a lathe, we want to go to the chuck feature tab, and let's change it from a 4-inch step chuck, and let's move it over to a 8-inch 3-step chuck, and then we'll say OK. So we defined the machine. What this did is quickly prepare CAMWorks for your CNC machine and tools. And now we'll go to the second step, which is to set up the coordinate system, stock size, and the turn setup. Again, working with the CAMWorks 2018 tab, we'll move to the right and we'll start at the top here at the coordinate system. And I pre-built a SOLIDWORKS coordinate system. I'm using SOLIDWORKS, and I created and I called it lathe operation 1. And you notice when I did that, it changes we have the Z direction correctly here and the X direction. We'll say OK, and then we move to the stock manager. This part is 1.5 inch OD, which is great because you can get that as a stock size, so we'll just leave it there. The only other thing we want to do is we want to add 150 thousandths to the positive and negative X for cleanup and for holding the part. So I'm going to add 150 thousandths, and you'll notice that not 15 thousandths, but 150. We can verify that it's been put in there, and again, we're using a round bar stock. And then we're going to set up the turns setup, and you'll notice it here, Z direction, X direction. We're good with that. We'll say OK. With the second step of the workflow, we prepared CAMWorks for the CNC machine's work coordinate system and expected stock size. Step 3 of the workflow is to extract machinable features and let's generate operation plan. So in SOLIDWORKS, again, working with the CAMWorks 2018 tab, we're going to start with the extract machinable features. And what you'll notice is as we select these icons and we go through these processes, the icon to the right will become available. So again, as we finish doing the extract machinable features, generate operation plan will become available. When we process that, generate toolpath will become available, and then simulate toolpath, and then finally post-process. So let's go ahead and start with the extract machinable features. And we'll see here under turn setup 1, we have our face feature, OD feature, groove, ID, groove, and cutoff feature. I'm just going to show you the setup out of the box. So we're just going to continue on. I know we said we're going to split the operations into 2, but let's just see what it gives us out of the box. We'll generate the operation plan. And you notice once we do that, here in the feature tree, these features got processed. So it went from magenta to black, and then we'll move over to the CAMWorks operations tree. And again, we'll see all these items here. These are the different operations for the features. And what I really want you to pay attention to is the yellow here. That's just letting you know that the tool was not in your tool crib and it was added from your library to your tool crib. And we'll see that it's added, again, several tools here. Tool 1 is a, looks like a CNMG 16 thou 80 degree diamond. Tool 2 is a finisher. It's a 16 thousandths 55 degree diamond. That's a DNMG. And so again, some other tools are just added on down the path here. So we completed step 3. We let AFR automatically find the model's machinable features and select machining practices for those selected features. Let's go ahead and again go to step 4, generate and simulate toolpath, and let's see what we get. Again, this is from an out-of-box experience. So in SOLIDWORKS, again, we're working with the CAMWorks 2018 tab. We go to generate toolpath, and you notice the operation tree items went from magenta to black. It means they're the toolpaths. So we look at this, and let's see how this performs to our machining plan. So just to review, our machining plan says that we're going to face, we're going to want to rough and finish, we want to turn the OD, we want to do a groove operation, rough and finish, we want to do a drill operation, a bore, rough and finish, then a thread on the ID. Okay, so we're back inside SOLIDWORKS. We're going to go do a simulate toolpath, and we see that it did a lot of operations, but I'm not sure if it's what we expected. Remember, we said we wanted to do this in 2 operations. It did it in 1. Let's see what the part looks like, the simulation to the actual part model. We'll select that by showing the difference here. And we can see that the bore here is undersized, and there's obviously no thread operation there. The groove operation looks good, and we should split this operation too because this should be cut and it's not, and that's why you see that it's undercut by a significant amount. So what we'll do is let's go ahead and exit out of this, and let's go back in and let's make some corrections. Our machining operation plan for lathe operation 1 has us doing a bore, rough and finish, and a thread operation on the ID, and that's not happening. So let's go back and look at the operations and let's make the changes that we need to make this part. In SOLIDWORKS, we're going to work with the CAMWorks operations tree, and we'll notice that we have some of the operations here, but we have some extra ones. We don't need an internal groove rough or finish or a cutoff. So let's go ahead and remove those operations. We'll select them, right click, delete, and we also have a problem. These items are going back a little too far. The turn rough and turn finish, it should not be doing that. We should only be cutting this little amount here. So let's go ahead and make those changes. So in the turn rough, I will come here, I will right click on the turn rough operation, edit the definition. I'll go to the advanced tab, change the Z limits, the ZN from whip to user define. And I want to change this so that it actually comes to this point here. And you'll see that it's minus 7 thousandths. We'll say OK. And you'll see that it turned, the system said, well, turn rough is not going to do anything because it's there's nothing for it to do with that, so I changed it back to magenta. Let's go to turn finish and let's change the feature depth, the Z depth. Again, we'll go to the advanced tab, change it to user define, select points, and this time instead of back saying minus 1 inch, what we're going to do is we're just going to type in do the math so that we make it 0.007. So what we'll do is we'll have SOLIDWORKS do the or CAMWorks do the work for us. So we'll do 1 minus 0.007, and you see that it makes the value 0.007. And again, you see it reflected here. We'll say OK. And you see the toolpath changes just for that little bit. There is no turn rough operation, which is expected. So then we come down, we have a groove rough on the OD, then groove finish, center drill, and then drill. So now we need to add 2 operations, actually excuse me, 3 operations. We need to add a bore rough and finish, and then a thread operation. So we've already removed the operations from lathe operation 1 that we actually need to do in lathe operations 2. But let's look at what we need to add to lathe operation 1. We need to add a bore rough and finish, and also we need to add a thread operation on the ID. But let's go ahead and let's add the bore rough and finish first. In SOLIDWORKS, we want to move from the CAMWorks operations tree over to the CAMWorks feature tree. And we want to look at the ID feature 1 drill. We want to right click, edit the definition, and we want to change the strategy from drill to rough finish. And you'll see here on the right hand side it's added some operations. We had the center drill and the drill, which we had previously, but we added a bore rough and a bore finish operation. And we also want to make sure let's go ahead and take a look at it and see what it gives us. Okay, let's regenerate. Center drill, bore rough, bore finish. Okay, so let's go ahead and generate a toolpath for this. Just control select items and then generate toolpath. Let's see the center drill goes on appropriate depth. The drill is also going a little farther than we want. We probably could do that, save some for the second operation. And the bore rough is going to the appropriate depth. And the bore finish is going a little deeper than we want. It's going all the way through. So let's go ahead and correct that. Let's change the drill operation. Let's right click on the drill operation, edit definition, advance, go to the whip, user define, and we want to go back to the depth of find here. User define, select a point, and we want to select this point here. And we want to do the math to make sure it goes back. Let's go back minus 1.4 because we want to leave a little bit of room for our boring bore. Let me do the math here real quick, just a moment. So we do 1.253 minus 1.4, and you see our total depth is z minus 1.4. You say OK, and you see it gets added in here. See OK. We see the drill depth has changed. Let's change the bore rough. Make sure it's going back the appropriate distance. So we'll right click, edit definition, change it from whip to user define, and again we can just add minus 0.3, leave us 100 thousandths difference. Again, we'll see the number here. And let's look at the roughing operation. That's a little too much depth of cut. Let's change that down to 32 thousandths, which is twice the tool nose radius. And we want to leave 20 thousandths and on the radial, and we want to leave 10 thousandths on the axial. Let's do a preview. We see the changes here. The number of cuts increases. That's good. We'll say OK. Bore finish. It's going too far back. Let's go ahead and change that. Edit the definition. User define. And we can change this again to minus 0.3. And let's look at the finish operations. And this is a little, again, too much for cuts. We left 20 thousandths from the previous operation. We want to use 20 thousandths, which is a little over twice, a little over the tool nose radius of 16 thou. And we want to leave nothing there. Keep that. Let's preview that, and we can see again it's changed the amount of cuts. And then we'll say OK. Okay, so that's how we add the bore rough and finish. Let's take a look at what we need to add next. So we added the bore rough and finish operation. Now we need to add the thread operation on the ID. So let's go ahead and do that. Let's switch over to the SOLIDWORKS. In SOLIDWORKS, we're going to use the CAMWorks 2018 tab, and we're going to go to Turn Operations. And we're going to add Turn Bore Operations. And the operation we're going to do is a thread. I'm not sure why it's not giving it to me. Let me try that again here just a moment. There we go. Thread operation. We're going to add a thread tool right there. And we're going to create a new feature. We went to the Features tab. Now we're going to create a new feature. And all we're going to do is we're going to grab this extent here and say OK. Strategy is not drill, it's thread. And we see here we have all the tools. And we'll say OK. And here we see the tool. And then again in the feature tree, you notice that the thread operation is magenta. We can right click on that and generate the tool path. Now we have all the operations that we wanted for lathe operation 1. Let's go ahead and do a simulate tool path. One thing I want to mention here is that you can model your tools so that they are correct in size. Um, this part should still be correct here. You'll see the threading operation. It just didn't represent it quite accurately, but this is the correct tool path. So we look here, everything else is green. Let's go ahead and save this as a STL so we can use it for our next operation. And we do that here. Save work whip as STL. Again, notice that there's a little guide here that shows you what the different colors mean. So we finished programming the part for Lathe 1 for the Haas ST20, and now we need to do the Lathe 2 on the Okuma LB15. Let's take a look at the machining plan. Again, we need to do a face, rough and finish, turn OD, rough and finish, a drill operation, a bore finish, a groove finish, and then a thread operation on the OD. The workflow for the second operation is the same. We got to define a machine, set up a coordinate system, stock size, turn setup, extract machinable features, generate an operation plan, generate and simulate toolpaths. I've done some of these just to not to be repetitive, but let's take a look at what I've done so far. So I've defined the machine, turn single turret, tool crib. We're using tool crib 1. You'll notice that it's populated with the tools from our first operation. Post processor is an Okuma LB15. And the chuck, I changed it to a 10-inch 3-step chuck. The coordinate system, again, I'm using a coordinate system I created in SOLIDWORKS coordinate system using Lathe 2. And again, you'll notice it here, the Z in the X direction. And then the stock manager, again, we're using 316 stainless steel. Instead of using the round bar stock, we're actually going to be using the whip STL file that we created. And you'll notice it here, you'll see that the lathe operation 1 items are removed, the OD groove, the thread, and you see the turn setup has been created, the Z position and the X. And you also notice that I did the extract machinable features, and we have some features listed here, but not quite all that we need. And before we generate an operation plan, let's make some changes here on the feature tree. This ID feature drill 1, this should not just be drill only, but it should also be a bore finish. So let's go ahead and make that so. So we'll right click on this item, edit the definition, change it from just a drill only to a rough and finish, and you'll see that it adds in those operations. And I don't believe this bore rough is going to happen because there's just not enough material, but let's see what happens when we generate an operation plan with that. Okay, so we're going to generate an operation plan. Everything went from magenta to black, so let's move over to the operations tree. And we see we have a number of tools, items going here. So let's go ahead and generate a tool path. Okay, looks like everything went in, even the bore rough. And the bore finish. There's no rougher for the groove, it's just a finish groove. But we're missing the OD thread, so let's go ahead and add that here. So we'll go to turn operations, turn bore operations, excuse me, turning operations. This is the OD item. And we want to select thread. Our tool is going to be OD thread. That's an ID thread tool, I believe. So let's go ahead and take a look at what we have for. There we go. And then the feature that we want to select, let's create a new feature. And we will select this extent here. And then make sure we use a strategy thread. And then say OK. And let's preview that. And we see the thread operation there. Say OK. And let's simulate this part. So I'm going to go ahead and simulate this part. Let's do a compare. Okay. So AFR wasn't quite 100% accurate with some of the toolpaths, but you do see that the internal groove is good, and the external thread is also good, and the part overall is good. There looks like a little bit of issue with the bore operation, and that's something that we can fix later. Thank you for taking time to watch this webinar on making grooves and threads on the OD and ID. My name is Charles Woolridge, and I'm an applications engineer for GoEngineer.